Hello. Okay, everybody. Look, what we're going to do today is we're going to learn Heron's formula. We're going to derive it. We're going to prove Heron's formula. Heron's formula is a formula for the area of a triangle given only the side lengths of the triangle. And it's any triangle that this will apply to, and that's what we're going to prove it for. So we're going to get a formula for, if we know the side lengths, we know A, B, and C, then we will be able to produce the area of this triangle. Now, this proof, this derivation is extremely algebraic heavy, so there's going to be a lot of algebra. So that's fair warning that there's a lot of tedious algebra in this, and I'm going to try and do this with you. I tried it one time before. Let's try it one more time because I messed it up. That's how much it's a mess. You just got to do it a few times before you feel a little bit more confident. And this is my second attempt. I tried to do the first attempt, failed. Now this is my second attempt. So let's see if I can do it on my second attempt. Okay, so now look, what we have here is a triangle with side lengths A, B, and C. Now, I draw this altitude from one of the vertexes down, and I call that altitude length H. Okay, we know that the area of a triangle is, of course, this A, the base, times H divided by 2. But we don't know what H is, and that's essentially what we want to do. We want to just basically get H in terms of A, B, and C. Because once we get H in terms of A, B, and C, then we can just substitute in that formula, and then we're done. So how do we start? Well, basically what we do is we start with this. We call this length X. And if from here to here is X, we should easily see that then from here to here is A minus X, right? If this length, if A is 10 and then X is 3, then what's left is 7, 10 minus 3. So if this whole length is A and this length is X, then that length is A minus X, easy. Now, we use Pythagorean theorem repeatedly, okay? The first part is not too bad, but using Pythagorean theorem, we're going to get that for this triangle on the left, right, we're going to get x squared plus h squared is equal to c squared. That's 1. 2, we're going to get, if we look at this triangle on the right, we're going to get a minus x squared. That's the length of this leg. Plus h squared is equal to b squared. Now what we do here, and the steps that you take seem random, or they seem arbitrary, right? And they sort of are, but at the end of the day, they allow us to do what we want, and that makes them not arbitrary. They just seem arbitrary. It's like, do this, do this, do this, jump through this hoop, jump through this hoop. It doesn't, it seems random. But at the end of the day, you jump through all the hoops, and then you actually achieve the goal. So stick with me while I run through these seemingly arbitrary steps. I'm gonna jump through this hoop, jump through that hoop, and it's gonna be a whole mess. But at the end of the day, we get what we want, and that's what's important. So what's the first hoop that we have to jump through? The first hoop is that we take this equation and we minus this equation. So you want to minus the left-hand sides and minus the left-hand sides, and then you want to minus the right-hand side. So I get x squared plus h squared minus this whole left-hand side, a minus x squared plus h squared is equal to the right-hand sides, c squared minus b squared. And that's the first step, really. I mean, then what you do is you say, distribute this minus a x squared minus h squared is equal to c squared minus b squared. And then you should see that the h squareds cancel, and then you have x squared minus a minus x squared is equal to c squared minus b squared. And then this foils out. When you foil it out, you get minus, I'm going to put it in parentheses, a squared, and take your time with foiling it out, right? Do a minus x times a minus x. Sit there and distribute if need be. I'm going to skip that step. Minus 2ax plus x squared is equal to c squared minus b squared. And then I distribute the minus. So distributing the minus, I get x squared minus a squared plus 2ax minus x squared is equal to c squared minus b squared. And then the x squareds cancel. You get negative a squared plus 2ax is equal to c squared minus b squared. And the whole purpose of this is to solve for x. That's the whole point of this. That's the first big hoop you got to jump through, right? Why are we solving for x? I don't know. Let's see why. I have no idea why. Okay, this is what we do. Okay, plus 2ax is equal to c squared minus b squared. I add the a squared over the other side. A squared plus c squared minus b squared. And then I have 2ax. I divide by 2a. And I get x is equal to this expression right here. And this is not too bad. Now that's step one, and that's the easier step, I'm not going to lie. So we got to remember what x is. So I'm going to go to another page, and I'm going to remember what x is. And I got x is equal to a squared plus c squared minus b squared all over 2a. And then now what I do is I'm going to plug this in to a formula that I get for h squared. So remember in the beginning we had this formula x squared plus h squared is equal to c squared from regular Pythagorean theorem. This formula immediately implies that h squared is equal to c squared minus x squared. But here's where you really got to be strong with the algebra for this, because you got to remember that h squared, that c squared minus x squared is what's known as the difference of two squares. And there's a way to factor this as c plus x times c minus x. And we have to know the difference of two squares is, c plus x times c minus x. Now, after I have that, I use what I got for x, and I plug that in to right here, right, for each of them. And then I'm going to get h squared is equal to c plus, and we got to take our time with this, a squared plus c squared minus b squared over 2a, right? And then I get c minus, and I'm going to put in parentheses, a squared plus c squared, plus c squared minus b squared over 2a. And now what I do is I'm going to get a common denominator between the two. So the common denominator here, right? So what do I mean? The common denominator in here. So here, this is c over 1. But I want that to have the same denominator as this term right here. So the common denominator is 2a. So I multiply by 2a on the top and bottom. I'm going to get h squared is equal to 2ac plus, now it's a common denominator, a squared plus c squared minus b squared, all of it over 2a, times the other one, same thing, 2a on the top and bottom over here. Going to get 2ac, and I'm going to distribute that minus a squared minus c squared plus the b squared over 2a. Now I have h squared is equal to, and I'm going to rearrange the terms again, seemingly arbitrary. I'm going to put it as a squared plus 2ac plus c squared minus b squared over 2a. And then I'm going to put negative a squared plus 2ac minus c squared plus b squared over 2a. And this is where it starts to get really tricky, okay? We just got to investigate what's happening with this and this. So we have to notice something about this, which is very tricky. And we just have to notice, I'm going to put it up here, a squared plus 2ac plus c squared is equal to a plus c times a plus c, right? If you distribute, you get back the original one, a squared plus an ac plus another ac plus c squared is the original. So instead of writing that, I write h squared is equal to a plus c squared minus b squared over 2a. And then similarly, if we investigate this one, negative a squared plus 2ac minus c squared. Okay, that's the same thing as negative 1 a squared minus 2ac plus c squared, and that's much more easy to factor. That's a much more understandable thing to factor than the minus in the front. So negative 1, right? And then what multiplies to c squared but adds to negative 2c, negative c. So this becomes a minus c times a minus c. And again, you could distribute and convince yourself that this is true. So now instead of writing that, I'm gonna write it as b squared minus a minus c squared all over 2a. I think that this is the best way to write it. Let's see, because this is my first time doing this, or second time. Actually, this is my first time up to this step because I messed up on this step last time. And now we got to know something tricky again. We got to see that this here, right, is the difference of two squares. And this here is the difference of two squares, right? So what does that mean? What does that look like and why? So we got to remember that it doesn't matter what it is, right? Let's use x, let's use z and w. Z squared minus w squared is equal to z plus w times z minus w. But if you look, this whole thing could take the role of z. So this thing factors as a plus c minus, this is just b, like w is b, right? Minus b times a plus c plus b, right? And that comes from the difference of two squares formula. And similarly, this here, right? This becomes b minus a minus c times b plus a minus c. And it's all over 4a squared, right? When I multiply the denominators together. Now, this is h squared. So what I can do is let's see. Let's talk about semi-perimeter. Let's see. What do we have here? B, yeah, that's fine. I have that term. I have these terms. Okay, this is pretty much the formula now, because what we have here is h squared in terms of a, b, and c, and it gets as simple as possible pretty much. So what we have now is that, I have to somehow copy this over. Yeah, I could do that. Okay. So what we have now is, and this is again my first time doing this, this here, what we have now is we got h squared is equal to, and when you do the algebra on that last page, right, when you do the algebra over here, right, let's see if we could do it over here. Let's see if we can fit it. 4a squared. This is a plus c minus b times, right, this is a plus c plus b, or a plus b plus c, the next one, right? And then this one, the minus distributes, so you're going to get b minus a plus c. And then the last term I'll put up here, and this is b plus a minus c. And now you have h squared in terms of a, b, and c. And that's what's ultimately important. Because then you rewrite it, h squared is equal to, and again, I'm just going to rewrite that expression probably in a different order, b plus c minus a times a plus B minus C, and then A plus C minus B, and then A plus B plus C over 4A squared. Now, we got to introduce another term. It's just a nice way to simplify how everything looks. We're going to call S the semi-perimeter of the triangle. And it's just the perimeter of the triangle divided by 2. So the perimeter of the triangle is A plus B plus C divided by 2. And that helps us simplify, because now we're going to get H squared is equal to, if you notice, look, if we look at this, let's see what we got. We got that this, okay, so 2S, that's better, 2S is equal to A plus B plus C, right? And what we should see is that this, we want to substitute this in for each term sort of in a strange way here, right? So what is it? So what's the relationship? How are we going to do this? Okay, so if you look, 2S minus A is equal to B plus C, right? For this. So let's see, is this right? So then B plus C, instead of me writing B plus C here, I write 2S minus A minus another A, and then that term becomes 2S minus 2A. And you just play this game with each term. So A plus B in this, 2S minus C is equal to A plus B, right? So instead of writing A plus B here, I write 2S minus C, but then there's another minus C, it becomes minus 2C. And then again, instead of A plus C, right, it's, what is it? It's going to be that 2S minus B is equal to A plus C. And then you write that in for A plus C, you're going to get 2S minus B minus another B is minus 2B. And then the last one is just 2S, right? A plus B plus C, this is just 2S. And then all over 4A squared. And then now you have H squared. You want H. But though, factor out the 2 and divide by 2, I suppose, right? Let's see. So we got 2. How many 2's do we factor out here? So there's 1, 2, 3, 4 2's. So it's 2 to the 4th. It's 4, right? S minus A. S minus C. S minus B. And then S over A squared. Yeah. And that's H squared. Now we write H in the square root, and the 4 will come out, S minus A, and the 2A will come out, right? It's 2 over A. And then everything else is in the square root, S minus A, S minus C, S minus B, and then times S. And that's H. And then once you have H, then you go back finally and you say area is equal to A times H over 2. And then H is this entire thing. And then the A's cancel, so you just get the square root. The A's cancel, look, this term is the same thing as this, but the reciprocal. So when I multiply, they're going to cancel out to 1, so I just get this as the area, which is nice, over S minus A times S minus C times S minus B times S, where again, S is the semi-perimeter. So this is all in terms of A, B, and C. And this is known as Heron's formula. So go through this, okay, be able to do this. Heron's formula, let's write it big, bomb.